Hello everybody. I'm recording this video for students that might have missed the exothermic and endothermic lab that we did in chemistry. The importance of this video is that even though you might have missed the lab, you still have to be responsible for the concepts that are in it, and I want to go ahead and help you guys out without having to take you into the lab setting. So first of all, before we get started, you guys need to understand there are three parts to this lab report that you'll need to turn in. The first one being some sort of a modified procedure, which I will go ahead and kind of verbally describe to you guys. The second one being a data table, which I'll fill in as this video progresses. And then thirdly, you'll have to take that data table and turn it into a graph. So go ahead and getting started. The first part of any good procedure is that we should know what materials we're working with. And in this case, we've got two different small reactions that we're going to be doing. And I'll focus on the first one first, and then I'll go ahead and describe the second one. The first one we're going to be working with is a reaction between hydrochloric acid, which is a liquid, and a magnesium ribbon, which is a solid. Now, to be more specific, I'm going to be dealing in 10 milliliters of hydrochloric acid, and the magnesium ribbon, the size of which isn't really significant. The third part that we'll have to work with is our thermometer, which I'm just going to abbreviate thermo, and that's to detect the temperature change. So once I've gotten my materials together, what happens is you put the magnesium ribbon into the hydrochloric acid and you'll see a reaction take place. And what our goal is to measure the heat generated or taken in by the reaction. Now, as we should be doing with every lab, if we're dealing with temperature, we have to take what's called a time zero reading. And this is basically the temperature of the liquid before anything happens to it. And for most of us, that temperature is going to come in at 20 degrees, and our temperature we should be measuring in degrees Celsius. So once I've gone and taken my magnesium ribbon and I've go ahead and add it into my hydrochloric acid, kind of like how my little arrow is right here, what happens is it starts to bubble really rapidly, and you should be watching the thermometer. Now, if I'm recording every 10 seconds, what happens is after about the first 10 seconds, I've gone up to about 22 degrees. By 20 seconds, we're looking at 23. By 30 seconds, it's jumped up now to 25. By 40 seconds, we're looking at 26. By 50 seconds, we're probably at 26 again. And at 60 seconds, we are finally at 27. Now, by the time it hits 27, this reaction has fundamentally ended. It's not going to go much higher than 27 degrees. So there's a couple of very good data points for you for the first reaction. Now let's go ahead and take a look at the second one. The second one, what we're going to be dealing with, once again, we have our thermometer because we're measuring a temperature change. The liquid that we're dealing with right here is good old H2O water, and we've got a weird powdered salt that's ammonium chloride. So it's a powder, very powdery substance. Looks kind of like sugar, but you definitely don't want to taste anything that we have in lab. It's called ammonium chloride. Now, once again, we're going to go ahead and take our thermometer and put it in the water first to get a temperature reading. And just like in the first one, we wind up with about 20 degrees. And once again, that's in Celsius. So we go ahead and mix our liquid. What you'll wind up is you pour the water into here, and then you quickly put the thermometer inside of it, and what happens is that you start seeing a different type of reaction. And by 10 seconds, we've actually started dropping temperature. We're at 18. 20 seconds, 17. That's a terrible 7. 17. 30 seconds, we're at 15. 40 seconds at 14. By the time we've reached 15 seconds, we're at 13. And at 60 seconds, we're still at 13 because this is about where that reaction ends. So once again, we've gotten ourselves a number of data points. One of these reactions is exothermic. The other one is endothermic, and that'll be part of what you have to do with the graph. So what you guys should be doing now, go ahead and summarize the procedure as I just described it. Create your data table based on the information that I've given you right there. And then go ahead and graph out these two data tables to show the trend in temperature. Now, once you finish with your graphs, what I need you to do is I need you to label one of those graphs exothermic, and you're going to label the other one endothermic. And so we'll be testing to see how well you guys really understand those two concepts. Good luck!